Question number 1. The power of a water pump is 2 kilowatts. If G is given as 10 meters per second, the amount of water it can raise in a minute is to a height of 10 meter is. Options are A 200 2000 liters or 1000 liters, 100 liters or 1200 liters. So we need to find the power, which is having the formula mgh upon p. H is the height and mg is the amount, the m is the mass and g is the acceleration due to gravity. Now we can change the formula in terms of mass. So the formula becomes m equals to p multiplied by t upon g multiplied by h. Here the power is given as 2 kilowatts. In watts it becomes 2000 watts multiplied by the time, that is 1 minute. So in seconds it's 60 seconds upon 10 multiplied by the height is 10. So the value comes out to be 1000 kg. So it is equivalent to 1000 liters. So the option is D, 1200 liters. A body of mass 4 kg is moving with a momentum of 8 kilograms 8 kg meter per second. A force of 0.2 Newton acts on it in the direction of the motion of the body for 10 seconds. Increase in the kinetic energy is. Okay, the increase in its kinetic energy is given to be, we have the options 10 joules or 8.5 joules, 4.5 joules and 4 joules. Okay, so firstly we need to find the momentum of the body. It is given, so momentum is equals to which is equals to the mass into velocity. So p will be equals to m into u. So u becomes equals to p upon m, where u is the initial velocity. So using this we have 8 upon 4, that will give you 2 meter per second is the initial velocity of the body. Now force is equals to mass into acceleration. So your acceleration here equals to force upon mass. So therefore your acceleration becomes equals to force upon mass. Force given is 0.2 newtons upon the mass is 4 kgs, which is equals to 0.05 meter per second square of acceleration. Okay, so we find the acceleration. Now the distance traveled by the body in the motion for 10 seconds is given by the formula, where you can use d is equals to ut plus half at square, the kinematical equation s equals to ut plus half at square. So here you have the initial velocity 2 multiplied by the time 10 seconds plus of half multiplied by a, that is 0.05 multiplied by the time, that is again 10 square. So that gives you a distance which is equals to 22.5 meters. Okay, now we need to find the change in the kinetic energy, that is the work done. So work done is equals to force into displacement. So that is the distance. So 0.2 into 22.5. So the answer comes out to be 4.5 joules. So the work done, that is the kinetic energy, work done or the kinetic energy increase in the kinetic energy is 4.5 joules. Okay. A body constrained to move along the y-axis is subjected to a constant force of I1 plus 2j plus 3k, I plus 2j plus 3k newtons. The work done by this force in moving the body of a distance 4 meters along the y-axis is. So we need to find the work done by the body. So first we have given the force, which is equals to minus I plus 2j plus 3k. So minus over here. So we have the as the body moves from the distance of 4 meters along the y-axis, so distance becomes equals to 4, that is along the y-axis. So I, j, k, we have 3 axes. So j axis, along the j axis it is 4 meters. Now the work done is given by force into displacement. So force is minus I plus 2j plus 3k into the displacement, which is equals to 4 in the j. So that gives you 8 joules of work is done. So B is the correct option. A block of mass 1 kg is pushed up in a surface inclined to horizontal at an angle 30 degree by the force of 10 Newton parallel to the inclined surface as shown in the figure. Okay, so the coefficient of friction between them is 0.1, and as the block is pushed by the 10 meters along the incline, then the work done against the gravity is. Okay, we have a block somewhat over here like this. Okay, then we have an angle theta, it is pushed by an angle theta of 30 degree. Okay, then we need to find the forces, we need to find the work against the gravity, work done by the box against the gravity. So here mass is given to be 1 kg, also theta is given to be 30 degrees, also force is equals to 10 newtons, and the coefficient, friction coefficient is 0.1, that and the distance is the distance is a block of mass 1 kg, Newton surface at an angle, friction is pushed by a distance of 10 meters. Okay, so we have the distance as 10 meters. So the work done against the gravity is, W, which is equals to mg d sine theta. Okay, so it becomes equals to mg d sine theta. So m is 1 into g is 10 into the distance d is again 10 into sine of 30 degree. So that gives you the answer to be 50 joules. So 50 joules of work is done. So B is the correct option. A particle is acted upon by a constant force 4I plus j minus 3k and 3I plus j minus k is displaced from the point I plus 2j plus 3k to point 5I plus 4j plus k. The total work done by the force in SI unit is. So we need to find the total work done by the force. So we have given the acted upon by two forces. So we have F1 which is equals to 4I plus j minus 3k and F2 which is equals to 3I plus j minus k. Okay, so and the displacement from the point, we have displacements r1 I plus 2j minus plus 3k and r2 equals to 5I plus 4j plus k. Okay, so the displacements, the total displacement is r, which is equals to r2 minus r1. So we can have 5I plus 4j minus plus k minus I plus 2j plus 3k. So solving the minus terms, we get 4I plus 2j minus 2k. Okay, this is the displacement. So work done is nothing but combination of the forces F1 plus F2 multiplied by the distances, a distance r. So F1 plus F2 is 4I plus j minus 3k plus 3I plus j minus k multiplied by 4I plus 2j minus 2k. Okay, on solving this equation we get 28 plus 8 plus 8, that is 40 joules of work is done. So B is the correct option. A uniform chain of length L and mass M is lying on a smooth table and 1/3 of its length is hanging vertically downwards over the edge of the table. If G is the acceleration due to gravity, work required to pull the hanging part of the table is. So again we have the weight of the hanging part is 1/3 of the weight is lying on the table. So the weight of the hanging part is the total weight upon 3, that is L upon 3, and that is equals to 1 by 3 mg. Okay, that will be the total weight. Now the distance, the weight which acts along the center of the gravity of the chain will be half of its length. So that will be L upon 6, that is equals to 1 by 3 into half of the length, that is equals to 1 upon 6 L. Okay, so work done is equals to force into distance. So force is given by the total force is 1 upon 3 mg into the distance given is L upon 6. So we have mgl upon 18. So D is the correct option. An electron and protons are detected in a cosmic ray experiment. The first with the kinetic energy 10 kilo electron volt and the second with the 100 keV. The ratio of their speeds is where Me and Mp are the masses of the electrons and the protons respectively. Okay, so we have given the kinetic energy of the electron which is equals to half m EVE square for the electron. We can take it as it is given as 10 electron volt, and the kinetic energy of the proton, that is equals to half mpvp square, which is equals to 100 electron volt, as it is given at 100 keV. So we have the kinetic energies of both the electrons and the protons. Now we get the ratios of their kinetic energies of the speed is, so that is meve square upon mpvp square is equals to 1 upon 10. The ratios of the kinetic energies comes out to be 1 upon 10. So taking the velocities in concern, we have ve square upon vp square, which is equals to 1 upon 10th of the masses, that is mp upon me. So we need to find the a ratio of their speed. So that is equals to VE upon VP can be equals to under root 1 upon 10 MP upon ME. So the B is the correct option. The blade of a windmill sweeps out a circle of area A. If the wind flows at a velocity v perpendicular to the circle, then the mass of the air density of passing through it at time t is. So now we have given the options A, V, P, T, that is area of cross section multiplied by the velocity multiplied by the density multiplied by the time. So we have different formats. So let's go for the sum. It is the volume of the wind flowing per second. We have the volume flowing per second equals to the area which is the area of the circle it is sweeping multiplied by its velocity. So the mass of the wind flowing per second will be upon that the mass of the wind flowing per second multiply gives you the area of cross section area of the circle it sweeps multiplied its velocity multiplied by the density rho. Okay, so the mass then again the mass of the wind passing through the time t. Again we have the mass of wind passing in time t is equals to area, velocity, density into time t. Okay, so we have the equation AV rho t, which is the first equation. So for option A is the correct option. A 120 kg mass has a velocity v, which is 2y plus 5j. At a certain instant, its kinetic energy is. We need to find the kinetic energy of the mass. So mass is given as 120 grams, which can be converted into 120 into 10 to the power minus 3. So that becomes 0.12 kilograms. Okay, next the velocity is given as 2y plus 5j. Okay, so we have the velocity. In order to find the kinetic energy, we have half mv square. So squaring the velocity, we get 2y plus 5j multiplied by 2y plus 5j. The answer comes out to be 4 plus 25, that is equals to 29. Okay, so kinetic energy again half. The mass is given as 0.12 kgs into 29. So it is 1.74 joules of kinetic energy is given. So D is the correct option. Two bodies A and B have masses 20 kgs and 5 kgs respectively. Each one of is acted upon by a force of 4 kg weight. If they acquire the same kinetic energy in time t and tb, then the ratio of the time A to time B is. So firstly we have two bodies, that is M1 which is equals to 20 kgs and M2 which is equals to 5 kgs. Okay, next the force acting on both of them is 40 Newton. Okay, so acceleration A1 is 2 meter per second square and acceleration for A2 is 8 meters per second square. Then acceleration we can have F is equals to m into A, so A becomes equals to F upon m. So for each one of them we can find the acceleration. So next we have the kinetic energies. Both the kinetic energies we have to equal them, that is m into v square, that is we have in the velocity we have acceleration and the time both squaring, which is equals to half m, and for the A we have A2, that is tb square. Okay, then we need to find the ratio for both of them. First we'll substitute the values. Half into the mass is given as 20 multiplied by 4, that is acceleration square becomes 4 multiplied by ta square, which is equals to half into the mass is 5 multiplied by a square, 8 square is 64 multiplied by tb square. Okay, so the ratio of the time ta to tb square will be equals to half into 5 into 64 upon half into 20 into 4, that gives you 4 is to 1. So removing the squares we get the value 2 upon 1, so the ratio is 2. Okay, so B is the correct option. Okay. A particle is acted upon by a force F which varies with the position x as shown in the figure. The particle is at x equals to 0 as kinetic energy 25 joules. Then the kinetic energy of the particle is x equals to 16 is given as. So we have the figure for the particle having the work done. The y-axis gives us the force and the x-axis gives us the distance. Okay, so work done will be the area which is covered under the graph. So that work done is equals to what we have in the graph is a triangle. a rectangle, again a square and a square. Okay, no, both of these are the rectangles. Okay, so we have one triangle and three rectangles. Okay, and so we'll be adding both of all of them, that is half area of the triangle multiplied by area of the triangle plus the area of this rectangle plus area of again the small rectangle plus area of this last one. Okay, so we have half into, for the area of the triangle we have half into base into height. The base is 6, height is 10, plus the area of the rectangle, that is base into height, so that is minus 5 into 4, minus 5 into 4 plus again we have 4 into 5 plus again we have 2 into 5. Okay, 2 into minus 5 actually. Okay, so calculating the terms, we have 30 minus 20 plus 20 minus 10, so we get the value to be 20 joules is the work done. Okay, so we need to find the kinetic energy of the particles. So according to the work energy theorem, the work done is final minus the initial kinetic energy, so that gives you the kinetic energy final will be kinetic energy at 0 minus plus the work done. Okay, so kinetic energy at 0 is 25 joules, it is given, and the work done is 20 joules, so in all we get 45 joules of final kinetic energy. So option is the correct option. A variable force given by the two-dimensional vector f is 3x plus 4j. Okay, 3x square I plus 4j, and x on a particle. The force is in newtons and x is in meters. What is the change in the kinetic energy of the particle as it moves from the point of with coordinates 2, 3 to 3, 0? Okay, the coordinates are in meters. Next, so we will be finding the coordinates. We have the given the force 3x square I plus 4j. Okay, this is the coordinates we are having. Now we will finding the work done, that is the work done is equals to the integral of force with respect to the displacement. Now we are having we will integrate it with the coordinate system from starting from 2 to 3 to 3 to 0. Okay, so 2 3 to 3 0 we are having 3x square plus 4j. Okay, I plus 4j multiplied by the distance, that is dx. We can take the distance as dxi plus dyj, that is that some distance along the I and some distance along the y, along the j. Okay, so integrating again 2 3 3 0 we are having integrating this with respect to x, we have 3x square dx plus 4 dy, which is equals to again 2 3 and 3 0 we are having d, that is x cube, that is 3x square, that gives you 3x cube upon 3, so 3 gets cancelled, so 3x cube plus 4y. Okay, so now applying the coordinates to both of them, that is the x cube plus 4y. If we apply the coordinates, that is 3 2 3 and 3 0, we are having 3 cube plus 4 into 0 minus 2 cube plus 4 into 3, that is once it is x, once it is vy, once it is x, once it is y. Okay, so applying it and solving this equation, we get 27 minus 20, which is equals to 7 joules. Okay, so plus 7 joules is the answer. A particle in a certain conservation fold fields has a potential energy given by V equals to 20 xy upon 2. Force exerted upon it is. So we have a certain conservative force field where the particle has a potential energy of 20 xy upon 2. Okay, so for a conservative field we have force is equals to minus gradient of v. Okay, so for the divergence we have formula I d by dabba x plus j dabba by y plus k dabba z. Okay, so that force becomes equals to minus of I dabba by x of v plus j deba by deba y of v plus k deba by deba z of v. Okay, on solving the v, on putting the v x y in these terms, we get minus I deba, it is deba v is given as 20xy upon deba x plus j is given as deba 20xy upon deba y plus k deba 20xy upon deba z. Okay, so now differentiating again, we get minus I, that is 20xy with respect to x, so we get 20y upon z plus y with respect to y, we get 20x upon okay, so that is 20x y differentiating with respect to x, we get here is z, also here we get z plus k is given as 20x y upon z square, that is at k. Okay, so this is the equation, that is minus 20 z upon y plus 20x upon z, putting the minus sum inside, minus 20xy upon z square. Okay, so that is the option. So we can have I, we can have j, and we can have k over here. So the correct option is minus 20 minus 20x minus 20xy. P is the correct option. A particle of mass m is moving in a horizontal circle of radius r1 under the centripetal force equals to minus k upon r square, where k is a constant. The total energy of the particle is, so we have given to find the total energy of the particle. So it is, the particle is moving in a horizontal circle, okay, in a centripetal force, so that force is equals to mv square upon r, that is the centripetal force, which is equals to k upon r square. Okay, so here we can have mv square is equals to k upon r, cancelling the r's. Then the kinetic energy of the particle is given by half mv square, which is equals to k upon 2r, that is half of k of r. So that is again, as we have the force, k is a constant of total energy of the particle, the centripetal force is equals to the minus change in the potential upon the distance. So therefore the potential energy u is given as infinity minus the potential energy runs from infinity to the distance r minus of f dr. Okay, we can have u, this equation in terms of u becomes f dr. Okay, so putting the values, we have minus infinity to r, we have a force which is equals to minus k upon r, the force which is equals to minus k upon r square, that is equals to this minus k upon r square into dr, that is, the k is a constant, it comes out infinity to r, minus minus becomes plus, so we have 1 upon r square, that r square will go upwards, so that becomes r raised to minus 2, so r raised to minus 2 dr. Okay, so integrating this, we get k upon r. Okay, that is minus 2 plus 1 upon minus 2, so that becomes minus 2 plus 1, that is minus 1 upon r. Okay, so r raised to minus 1, that will again become 1 upon r. So the total energy is given by the kinetic energy plus the potential energy u, so that is kinetic energy is k upon 2r, we found it over here, plus the potential energy is minus k upon r, so that becomes equals to k upon 2r minus k upon r, so that is minus k upon 2r. Okay, so the answer is minus k upon 2r. B is the correct option. A bullet of mass m moving horizontally with a velocity v strikes a block of wood of mass m capital and gets embedded in the block. The block is suspended from the ceiling by a massless string. The height to which the block rises is given by. So we have we'll use straight away the law of conservation of momentum over here. Okay, so we'll use straight away the law of conservation of momentum over here, that is the momentum of the bullet before, that is m plus capital M v square is equals to after, that is m plus capital M into gh. Okay, that is, this is the mass of the bullet, This is the mass of the block, mass of the bullet and the mass of the block. So we here the string, the height to which the block rises, the height we have here h after the bullet is fired and it is penetrated in the block. So we have after collision it is having the mass of the bullet plus mass of the block for plus mass of the bullet multiplied g multiplied by h. So this equation in terms of h we can get v square upon 2g. Okay, so again h is equals to 1 upon 2g into, we can have v which is equals to v which is equals to, we have mv in the momentum terms, we have mv plus m plus capital mv. So v becomes mv upon m plus capital M. Okay, so solving the above equation we have v square, so we have v square upon 2g into m upon m plus m the whole square. So that is the option A, that is v square upon 2g m plus m the whole square. An adult weighing 600 Newton raises the center of gravity of his body by 0.25 meter while taking each step of 1 meter length in jogging. If he jogs for 6 kilometers, the energy utilized by him in jogging is, the mass of the adult is given m, which is m weight of the adult, that is 600 Newton is the weight, and the height is given as 0.25 meters. Okay, then the length of each step is, length of each step given is 1 meter. Okay, so the number of steps he will be taking in 6 kilometers is, number of steps he will take in 6 kilometers is 6 into 10 to the power 3 upon, that is in meters, upon in 1 meter, that is number of steps he is taking in 1 meter will be, in 6 kilometers will be 6000 steps. Okay, so we get the energy, we need to find the energy utilized in jogging. So the energy utilized in jogging is E, which is equals to number of steps multiplied its mass multiplied the gravity multiplied by the height. So we have 6000 multiplied by 600 multiplied by 0.25. Okay, so the value comes out to be 9 into 10 to the power 5 joules of energy. So option B is the correct option. Okay. Two springs of springs constant 1000 Newton per meter and 2000 Newton per meter are stretched with the same force. They will have potential energy in the ratio 2 is to 1, 2 square is to 1 square, 1 is to 2, or 1 square is to 2 square. Okay, so we have the potential energy which is equals to U, which is equals to half kx square. K is a spring constant, so we have half into k, and x is the displacement. Now the spring constants are stretched with the same force, so we can have the same force with the spring constant k. So k cancels each other, we have f upon, this is a square, so we have f square upon, so we have fk upon 2k. Okay, this is a square, so 1k remains over here. So the potential energy we get is for this. So for the two springs we are having two potential energy, u1 into k1 equals to u2 into k2, the spring constant. So again putting the equations back, u1 upon u2 is equals to k2 upon k1. The spring constants of both of them are 2000 is to 1000, so that will give you 2 is to 1. So option is the correct option. Question number 18. A ball of mass m collides with a wall with a speed v and rebounds on the same line with the same speed if the mass of the wall is taken as infinite and the work done by the ball on the wall is. So the mass of the wall is given as infinite. If there is an infinite wall, then the displacement by the ball given should be 0. So hence the work done by the ball on the wall is 0. If the displacement is 0, then the work done has to be 0. So D is the correct option. A force of 4i plus j minus 2k and acting on a body maintains its velocity 2i plus 2j plus 3k meters per second. The power exerted is. So we have force which is equals to 4i plus j minus 2k and the velocity which is equals to 2i plus 2j plus 3k. Okay, then we need to find the power which is equals to force into velocity. So that will be 4i plus j minus 2k multiplied by 2i plus 2j plus 3k The answer will be 4 watts. Okay, so A is the correct option. Now, a pump on the ground floor of the building can pump a water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meters above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Okay, so here we have given the volume of the pump, volume of the water, that is 30 meter cube. Next we have time, which is 15 minutes, that is around 15 into 60 gives you 900 seconds. Okay, next is the height, which is 40 meters of height. Next, the density of water, that is 10 to the power 3 kilogram per meter cube. Okay, next the mass of the water pump, so the amount of the water is pumped is equals to the volume into density. So the amount mass is equals to V into density, as we know that volume is equals to mass upon density. Density is equals to mass upon volume, so we can have this mass is equals to velocity into volume into density. So that gives you volume is 30 into density is 10 cube, that is around 3 into 10 to the power 4 kg of mass is that. Now we need we'll find the power output, then only we can find the efficiency of the power consumed. So power output is watt is equals to work done upon time, that is mgh upon time t. So having the m as 3 into 10 to the power 4 into g, we can take it as 10 into h is 40 upon the time t. T is 900 seconds. Okay, so we get the power output is 4 by 3 into 10 to the power 4 watts. Okay, that is the power output. Now the efficiency of the pump is eta, which is equals to output, power output upon power input. Okay, so we can rearrange this as power input is equals to power output upon the efficiency eta, so that we can have is 4 by 3 into 10 to the power 4 upon eta is 30% of efficiency, so 30 upon 100, so that gives you 4 by 9 into 10 to the power 5. On solving this we get power of about 44.4 kilowatt. Okay, so 44.4 kilowatt is the correct option. Water is flowing in a river at 2 meters per second. The river is 50 meters wide and has an average depth of 5 meters. The power available from the current in the river is, they have given the density of the water is 10 to the power 3 kilogram per meter cube. So we have the power, which is equals to the kinetic energy of the water flowing per second, that is the kinetic energy of the water flowing per second. Okay, so that will be half into mass, that is equals to area of cross section into density into the velocity cube. So that will be half into the area of cross section is 50 multiplied by the density is 10 to the power 3 into the volume is volume given is here is 2 the velocity given is 2 to the power 3. Okay, so that gives you 10 raised to 6 watts, so that is 1 megawatt is the current. So B is the correct option. Okay. A ball falls under the gravity from a height of 10 meters with an initial downward velocity u. It collides with the ground, loses 50% of its energy in collision, and then rises back to the same height. The initial velocity u is. Okay, so if suppose the ball is at the initial velocity at a height at the initial its total initial velocity at height h is given by half mu square plus the original height, that is mgh. Okay, so energy lost after the collision is 50% of the total energy. It loses 50% of its energy in the collision, so that is energy lost is 50% of the total energy is half mu square plus mgh. Okay, so that becomes half mu square plus mgh. No, okay, then after the collision it rises back to the same height, so the ball rebounds to the same height, so we can have half mu square is equal plus mgh is equals to the original height mgh where the ball reaches. Solving this equation we get half 1 by 4 mu square equals to half mgh. So the initial velocity u comes out to be under root 2 gh, which is equals to under root 2 into 9.8 into height is 10. So the value is 14 meters per second is the initial velocity. So C is the correct option. A mass of 5 kg is moving along a circular path of radius 1 meter. If the mass moves with the resolutions with 300 revolutions per minute, its kinetic energy will be 250 pi square j joules or 100 pi square joules or 5 pi square joules or 0 joules. Here the mass given is 5 kg. We have radius that is given as 1 meter. The rotations are given 300 per minute, so we can calculate it in the seconds. That is 300 upon 60. That gives you 5 rotations per second. So the angular speed is given by the formula angular velocity omega, that is equals to 2 pi v. So 2 pi into 5 gives you 10 pi radians. Okay, then the linear speed with respect to the angular speed is v, which is equals to omega r, that is r omega. So r is the radius that is 1, and omega we have 10 pi. So multiplying we get the angular speed of 10 pi meters per second. Now we have to ask the kinetic energy, that is equals to half mv square. So half into the mass is 5 kg multiplied by the velocity square. So the answer comes out to be 250 pi square joules. So the correct option is A, 250 pi square joules. A ball of mass m collides with the wall with the speed v and rebounds on the same line with the same speed. If the mass of the wall is taken as infinity, then the work done by the ball on the wall is since the wall has infinite mass, therefore the total displacement is 0. So therefore the work done will be 0. A ball of mass m falls from a height h on the floor, which the coefficient of restitution is e. The height attained by the ball after 2 rebounds is okay. When a ball falls from a height h and it reaches the floor, the velocity is given by under root 2 gh. Okay, so by the definition we have the coefficient of restitution is given by velocity of separation upon velocity of approach. So rebound velocity is the coefficient of restitution multiplied by the under root 2 gh, that is the velocity height, and that is the velocity at which it reaches the height h. Okay, so rebound velocity becomes equals to e square h, that is rebound height. So after 2 rebounds the height will be equals to e raised to 4 h. Okay, so C is the correct option. Okay. A bob A of a pendulum of mass m released from the horizontal to the vertical hits the bob B of the same mass at the rest on the table as shown in the figure. If the length of the pendulum is 1 meter, what is the speed with which the bob B starts moving? Okay. So the velocity at which the bob A will move to the bob B, that is when the velocity at which it starts coming down from a height h is given by v is equals to under root 2 gh. So therefore here we have 2 multiplied by g is to be taken as 10 meters per second multiplied by the height, which is 1 meter. Okay, so we get under root 20, that is 4.47 is the velocity meter per second. So 4.47 is option A, it is the correct option. A spherical ball A of mass 4 kg moving along a straight line strikes another ball B of mass 1 kg at rest. After the collision, A and B moves with the velocity v1 and v2 respectively, making angle 30 degree and 60 degree with respect to the original directions of the motion. The ratio of v1 to v2 will be, so the scenario is somehow like we have one ball which is going and A which is going and colliding to the another ball B, which is then both of them are going in different directions. So if suppose A goes in this direction, B goes in this direction, forming an angle 30 degree and 60 degree with respect to the normal, then we can have the masses of the balls are 1 kg and the A is around 4 kgs. Okay, so applying the law of conservation of linear momentum, that is the momentum before and after For the perpendicular direction, we have the momentum before is 0 0, which is equals to, after the momentum is the mass multiplied with the velocity in the angle of 30 degree minus the v2, which is equals to 1 v2 into sine 60 degree. So solving this equation, 4v1 sine 30 equals to v2 sine 60. So v1 upon v2 is equals to sine 60 upon sine 30, that is 4 sine 30. Here there are zero zeros because the initial velocity, initial masses and the initial velocities, they will both comprise to because the linear momentum again along the direction perpendicular to the direction of the motion, that is along the y-axis, it will be 0 for the initial one. So we have sine 30, that is root 3 upon, will get this 4 into sine 30, so that will root 3 upon 4. Okay, so the option is A, root 3 upon 4. Okay, sum number 28. The negative of the work done by the conservative internal forces on a system equals to the change in, so total energy, kinetic energy, potential energy, or none of this. So the negative work done in a conservative system for in the conservative internal forces of a system, these are equal to the potential energy of the system. So the correct option is C, it is the potential energy of a system. So because the amount of work done in the negative part of it from the internal forces in on the system is the stored potential energy of the system. A body of mass 0.5 kg travels in the straight line with the velocity v equals to ax 3 by 2, where a is 5 meter per second meter. The work done by meter per second square, the work done by the net force during its displacement for x equals to 0 to x equals to 2m is. So here we are having the we are given the mass, that is 0.5 kg, and also we have given the velocity, which is equals to k x raised to 3 by 2. Okay, then where k is equals to 5 meter minus half into per second. Okay, so we know that acceleration a is equals to the change in velocity upon time. Also velocity is we have velocity is change in displacement, distance upon time, so we can have v is equals to dv upon dt. Now we differentiate the entire equation with respect to time, so we have v square, v is equals to kx raised to 3 by 2, so v dv is equals to k raised to 3 by 2. So differentiating, so the squaring of this equation becomes v square is equals to k square x raised to 3. Okay, so we differentiating both the sides with respect to x, we get 2v dv is equal 2v is equals to dv by dx is equals to 3k x raised to x square. Okay, so acceleration is equals to 3 by 2 times k square x square. Now we have force, which is equals to mass into acceleration, so force becomes equals to m into acceleration. Acceleration we already have 3 by 2, just add a term of m into k square x square, so we got the force, which is equals to this. Then the work done will be integral of force multiplied by the displacement d, so multiplied by the displacement dx. So integration is from x equals to 0 to x equals to 2 meters. So we have 0 to 2 meters, the force is 3 by 2 m k square x square into dx. Okay, so integrating the above values, we get w is equals to 3 by 2, which is a constant, m is a constant, so k square again is a constant, so for the x square we get x cube by 3. Applying 0 to 3 limits over there, we get 3 by 2 into 2 3s are 6, that becomes 3 by 6 multiplied by 0 0.5 multiplied by 5 square, so that is multiplied by this 2 minus 0, so that is equals to 50 joules. So 50 joules is the work done by the net force during its displacement. A mass of 5 kg is moving along a circular path of radius 1 meter. If the mass moves with 300 revolutions per minute, its kinetic energy would be. So the mass is given as 5 kgs and it has a radius r, which is equals to 1 meters. and the velocity, that is the number of revolutions, is v is equals to rotations per minute 3300 rpm. Okay, so in the second we have 300 upon 60, so we can have 5 rps, 5 rotations per second. Okay, so angular velocity omega is 2 pi v, so that is equals to 2 pi multiplied by 5, so that is equals to 10 pi radians per second. Okay, next the linear speed, sorry, the linear speed is equals to angular velocity multiplied by the radius, so that is 10 pi radians multiplied by 1 meter, so the linear speed is 10 pi meters per second is the linear velocity. So we need to find the kinetic energy, so kinetic energy is equals to half of m into the linear speed square, so that gives you half multiplied by the mass, which is equals to 5 kg, multiplied by the linear velocity, that is 10 pi, is equals to 250 pi joules, pi square joules. Okay, so this becomes square, so 250 pi square joules, so A is the correct option.